Greetings everyone and welcome back. Meet the air quality pendant, a compact SGP40 sensor powered device designed to monitor total volatile organic compounds TVOC and provide real-time air quality classification. This wearable system uses advanced sensor-based analysis to evaluate TVOC levels and deliver immediate feedback through the both visual and auditory alerts. When the air quality is optimal, TVOC level between 0 to 200, a green LED lights up. If TVOC rises to 201 to 300, the device signals a cautionary state with a yellow LED and a warning tone. For more concerning levels 301 to 500, an alert is triggered. A red LED illuminates, pair with a distant alert tone to indicate poor air quality. If TVOC surpasses 500 or the sensor encounters a failure, the system shifts into an error mode, activating a flashing red LED alongside a distant error tone. Compact, responsive and intuitive. The wearable air quality pendant ensures you stay informed about the air you breathe. Now let's talk about the sponsor of this video, which is DigiKey. DigiKey is a global leader in cutting-edge component distribution of electronics and automation products worldwide. They provide more than 15.9 million components from over 3,000 manufacturers with product in stock available for immediate shipment. Also, with their fast shipping and excellent customer support, you can always trust that your products will arrive on time and in top condition. So do remember to check out DigiKey for your next project. The SGP40 sensor operates optimally in controlled indoor conditions where temperature, humidity and airflow remain stable. The sensor is not recommended for outdoor applications as external environmental factors such as extreme temperature variations, humidity fluctuations, and direct exposure to pollutants can significantly impact its accuracy and reliability. For best results, the SGP40 should be used in indoor spaces like homes, offices, and industrial settings where air quality assessment is crucial. Let's examine the schematic for this project. At its core, the STM32U083KCU serves as this device brain. An ultra-low powered microcontroller built on the high-performance ARM Cortex M0 32-bit RISC architecture, running at a speed of 56 MHz. The STM32U083 series offer efficient high-speed storage, featuring a 256 KB of flash memory and 40 KB of SRAM, safeguarded by a hardware parity check. Additionally, it integrates an extensive set of enhanced I/O and peripherals, connecting through APB and AHB buses, along with a 32-bit multi-AHB bus matrix for optimal data flow. Here we have the bare bones setup that is required to run the microcontroller effectively, as well as the SWD connector or serial wire debug connector for programming the STM32 microcontroller, and another connector connected to the UART. The SGP40 is then used, which is a miniature single-cell fully integrated lithium-ion and lithium polymer charge management controller. For power input, there is a USB Type-C port that is connected to our power management controller's input side. Here, we are using a CR2032 coin cell holder as the power source here, which is connected to the power management controller's battery pin. We can attach a regular rechargeable lithium-ion cell or in our case a non-rechargeable CR2032 coin cell here. Because of its size, the MCP73832T is appropriate for portable applications where space is a problem. The power source is connected to the input of ADPL44, a CMOS low dropout linear regulator that operates from a 2.7 volt to 40 volt and offer up to 200 milliamps of output current. We are using this LDO to get a clean 2.5 volt output so our microcontroller can function properly. The STM32U08 is the project's brain, but the SGP40, a digital gas sensor, is unquestionably its muscle. The chip has a digital I2C interface and temperature control micro hotplate, which generates a humidity compensated VOC based indoor air quality signal. The SGP40 chip generates a digital raw signal that is sensitive to the majority of the VOC gases commonly found in the indoor environment and proportional to the logarithm of the sensing material resistance. This signal is intended for additional processing by the Sensirion's robust gas index algorithm produce a VOC based output signal that may directly use for indoor air quality applications. In addition, this design includes a buzzer for audio feedback. The buzzer can be powered straight from the GPIO pin, but this is not ideal. Therefore, a PNP transistor with its gate connected to the STM32 PB0 is used here. This design includes 4 SMD RGB LEDs that illuminates in green, yellow and red color based on the readings from the SGP40 sensor. The LEDs anode are connected to the 3 STM32 IO pins with a current limiting resistor in between. The IO pin controls the RGB LED's anode terminal. The ground of all LEDs are connected in parallel with the ground of STM32. The components for this project PCB file were positioned on the both top and bottom side of the board. The STM32 microcontroller is first mounted in the center of the board, followed by the Type-C port, the SGP sensor and the components that are needed. The buzzer is situated on the top side along with the PNP transistor as well. On the bottom side, we have the coin cell holder connected with the MCP7383 2T setup and the ADPL44 setup. Let's have a quick look at the code for this project, and it's a simple one. The code starts by first adding the essential libraries in our sketch. The DFRobots SGP40 library facilitates communication with the SGP40 sensor, allowing it to read TVOC values for air quality assessment. To play auditory feedback, play RTTTL is used to handle tone playback for the buzzer notification, general specific sound alerts based on the air quality conditions. Additionally, PT scheduler enables non-blocking execution, ensuring that the periodic tasks such as sensor reading, LED updates, and buzzer activate runs efficiently without delays. Finally, the hardware serial.h manages the LP-UART communication via the PA2 and PA3, enabling the transmission of air quality data for external monitoring or debugging purposes. Then the LEDs and the buzzer are assigned to the specific GPIO pins. The TVOC variable stores the TVOC index obtained from the SGP40 sensor, which is used to determine the air quality level. The tone request variable tracks the tone need to be played by the buzzer to indicate the different air quality condition, ensuring an appropriate auditory response. Additionally, fade step manages the smooth LED fading effect, allowing the system to gradually adjust the brightness based on the air quality classification. Using the PT schedule, tasks are set up for non-blocking execution. The setup function initializes serial communication, configures pin as output and play a startup tone, and initialize the SGP40 sensor. The loop function calls periodic tasks without blocking execution. The read and evaluate air function tells the TVOC levels and determines the air quality. The update LED fade function smoothly transitions the LED brightness for visual feedback. The play tone function plays the RTTTL melodies for each air quality. The show error state function activates an error state when the sensor fail or TVOC values exceed the threshold. We 3D printed an enclosure for our pendant in 2 colors to give the enclosure a dual tone aesthetic. We placed the coin cell in the coin cell holder on the rear side of the circuit. Next, we fitted the entire circuit inside the main body before attaching the lid, encasing everything in a nice compact package. To complete this pendant, we link a chain to the 2 hooks provided on the 3D body, transforming this device into a necklace. For best results, the SGP40 should be used in indoor spaces where temperature, humidity and airflow remain stable. In an office setting, air quality can fluctuate due to ventilation, electronics equipment and human activity. The monitor detects changes, helping maintain a fresh workspace. Indoor air quality in homes is crucial for comfort and well-being, whether placed in a bedroom or living area. This monitors provide clear feedback on air conditions, ensuring a healthier indoor atmosphere. Cooking releases various compounds in air. In kitchen, this device helps detect changes in air quality, making sure ventilation adjustments are made as needed. Designed for indoor applications, this air quality monitor ensures accurate readings in controlled environment. By avoiding unpredictable outdoor conditions, it maintains reliability for effective indoor air monitoring. Well, this is it for today, folks. I hope this project was informative and fun. If you made this far in this video, thank you and have a nice day.
DigiKey.